this was now last week, I think we started linear number patterns, and then remember I wrote down that a linear number pattern has a first or a constant first difference. A quadratic number pattern has a constant second difference. Okay, so that is how we are going to identify these ones. I'm just going to highlight this heading. Highlight this heading. I just wanted to go back to the linear pattern. I just want to make it kind of the same way. Oh, pattern is a constant first. Okay. Sorry, I just want to make sure that my notes look the same. All right, so a quadratic number pattern. This is a pattern with a constant second difference. So I'll show you what that means, obviously, so don't worry. Let me just get a nice example here in the book. And guys, this is a really nice section to get nice marks. So it is important that we are trying to pay attention. I know it's hot and it's late and we're tired, but yeah, let's just try our best. I'm just looking for an example. Let's look at for example, if we have 0, 3, 10, 21, 36, and then so on. And guys, in the text exam, they are just going to give you a number pattern. They're not going to tell you which type it is. Okay, so you need to identify, is it a linear number pattern? So you need to check, am I adding the same number every time? Okay, so let's see. From 0 to 3, do we agree that we're adding 3? All right, that's quite an obvious one. But then from 3 to 10, am I adding 3 again? Now I'm adding 7, hey? So there we see immediately we do not have a constant first difference. I'm not adding the same number from the start. Okay, what am I adding from 10 to 21? 11, right? Again, that's a different number. So these numbers that I'm writing in blue, right? These are the first differences, but it's not constant in this case. It's not the same number that I'm adding. What about 21 to 36? That is 15, hey? Are these blue numbers the same? No, so it's not a linear number pattern. Okay, so I'm going to write here on the side, first diff or differences, not constant. So as soon as you see that, guys, as soon as you see that your first difference is not constant, then you're going to look for your second difference. Okay, which I'm going to show you now. So I'll do that in a different color. Now you're actually going to look at the difference between your first differences. So from 3 to 7. What am I adding from 3 to 7? 4. So my second difference here is 4. What am I adding from 7 to 7? Also 4, hey? 7 plus 4 is going to give me 11. So there we see now that the second differences are going to be constant in this case. From 11 to 15, I'm also adding 4. There we go. All right, so the second differences in this case are constant. We have a constant second difference. Now, for a quadratic number pattern, we're going to have a different Tn formula. Remember, for the linear number pattern, we work with a plus a minus 1b. All right? That is only when your first difference is constant. If you have a constant second difference, we're going to have a different Tn formula. So I am going to write it down now. And guys, the only thing with the quadratic number patterns is you have like a couple of smaller formulas in order to find all the values. Okay, so you are going to have to memorize this. So the formula that we're going to use, so the general term or formula or rule of a quadratic number pattern and this is probably going to look familiar. You have seen this before when we work with quadratic equations at the beginning of the year. You guys remember we spent about 3 or 4 weeks just working on different types of quadratic equations, like solving by factorizing, using the quadratic formula. We did the K method, we did simultaneous equations, we did a whole bunch of quadratic equations. So the general term formula, again, we're going to say Tn, right? Just like for the linear number pattern. But now the formula is going to be an squared plus bn plus c. Guys, when we worked with quadratic equations at the beginning of the year, we said ax squared plus bx plus c. All right, so it's the same type of situation that we have here. Instead of x, we're just using n. Okay, n the term number. So I'm going to write here again, Tn is the general term, all right? Now for A, B, and C, we're actually going to have specific formulas that we're going to use. Okay, it's not something that you can just read off. A is not the same as for linear pattern in this case, all right? What was A again for linear pattern? It was the first term, not the first term here, all right? So you are going to have to follow specific steps. The first step that you're going to follow is you are going to say that 2a is your second difference. That is the formula that's going to allow you to calculate a. 2a is always your second difference. So how do you get a on its own? What did you do with that 2? You're going to divide the second difference by 2. All right, so you can actually do that straight or right from the start. A is the second difference over 2. That is the formula that you are going to use to find your A value. You always have to do that first. Once you have your A value, you're going to use your A value to find your B value. So the second formula that you must remember is that 3a plus b is term 2 minus term 1. That might be a difficult one to remember. You can also say that this term 2 minus term 1, if we look back at the example, I'll come back down now again, is that term 2 minus term 1, your first difference. Okay, term 2, which is 3, sorry, minus term 1, which is 0. 3 minus 0 is 3. So this first value that you calculate, the first difference that you calculate there, that is what you are going to use here. Okay, so you can add a little note there saying this is the first difference. Just don't want you guys to get confused because I've said first twice, right? But it is the first difference that you calculate. So guys, what's going to happen is you will have an answer for A from here, right? You'll have a number, you'll calculate it in the first step. You are then going to put that number there in the place of A. Okay, so this 3a is actually going to be a number as well, because you're going to calculate A in the first step. 3a is going to be a number, that's going to be a number, you're going to be able to calculate B. Then the third and the last formula that you're going to use is A plus B plus C is equal to term 1. Now remember, from the first step, we'll have a number for A, a value. So we're going to use that value there. From the second step, you're going to calculate a value for B. So we're going to use that value there. And term 1 is also a number from the number pattern. So you will actually have numbers for all of these except for C. Okay, you'll see now. We're going to do an example just now. So guys, I actually just want you to highlight that in this step here, we're calculating A. In this step here, we are calculating B. And in the last step, we're going to be calculating C. All right, so you calculate them in alphabetical order. First A, then B, then C. But you also need to memorize these three formulas. Okay, they won't be given. So that's the only thing that's difficult about this section, is that you have to memorize all of these formulas. Okay. I wanted to do an example quickly. I wanted to actually find Tn of this number pattern that we've done up here. All right, just so that you can see how this works. Do you guys have space on the slide to do the calculation? You want to do it underneath. Okay, it's fine. So let's say e.g. find the general term of the pattern. I'm going to rewrite that number pattern 0, 3, 10, what was it, 21, 56. Like I said, guys, I'm not going to tell you what kind of number pattern it is. You need to find that. So I'll just redo what we did above. You can just copy that plus, or those pluses that we filled in. So you would find your first difference. You would say, oh no, it's not constant. I'm not adding the same number each time. So now you check your second difference. Then you see, oh, wonderful, we are adding the same number each time. Then, all right, it's 4, and then 4 again, and then again 4. So the second difference is constant, so it's a quadratic. That's also something that you must memorize. So we're going to use this Tn formula. An squared plus Bn plus C. Now we're going to calculate A, then we're going to calculate B, then we're going to calculate C, and then we're going to write our Tn out, filling in those values that we found. Okay, to find A, what is the formula that we wrote down? A is the second difference divided by 2. So A is, the second difference is 4. A is 4 divided by 2. So my A value is 2. Step 1 done. Step 1, actually, I suppose, is first figuring out that it's a quadratic number pattern, but then you found your first value. All right, that's already a mark, guys. Second difference divided by 2, you have 1 mark. Okay, now we're going to say 3A plus B is equal to, what did we say? Term 2 minus term 1. The first value that we work on. 3. Remember the first difference, that's the second formula that we wrote down. 3A plus B is equal to the first difference. So the first of your first differences that you work on. We have a value for A though, don't we? So now we're going to put that value in this equation. We're going to say 3 times 2 plus B is equal to 3. You see why I had to work out A first, right? So that I don't have that variable in it. So I actually just have B to solve. 3 times 2 is 6. So this is 6 plus B equals 3. So to get B on its own, I need to say 3 minus 6, right? So B is going to be negative 3. Okay, B is calculated. We just need to still find C. The third formula was A plus B plus C is equal to term 1 of your number pattern, which is 0. So A plus B plus C is 0. But guys, we've already found the value of A. It's 2. So I'm going to put that in my formula now. And I've already found the value of B. It's -3. So I'm going to put a -3 there in the place of B. Plus C is equal to 0. What's 2 minus 3? That's -1, right? So -1 plus C is 0. So C is equal to, when you move that -1 across, it's going to become 1. So C is 1. So there we have our three values, guys. A is 2, B is -3, and C is 1. Get 1 mark for each of those values. And of course, if you calculate your A value wrong, say for example, you were having a bad day and you thought that 4 divided by 2 is 4 or something, you just made a mistake there. Then obviously your B and your C values will also be wrong, right? But because it all is because of one mistake, we will see A for the rest of it. So now all that's left for us to do is to actually rewrite this AN squared plus BN plus C with our actual values in the formula. Okay, so we're going to say therefore term N is AN squared. A is 2. So 2N squared plus 3N, which is now minus, sorry, I said plus BN, I said plus 3N, but I meant plus BN, sorry. B is -3, so that's -3N. And then plus C, so plus 1. Okay, and that's the answer, guys. So we're going to take some effort to memorize those formulas, but then after that, right? They can now ask you similar questions to the ones that we did for linear patterns. They can now ask you for term 25. What do you think we'll do if they're asking us for that? Term 25, what is N? N is always the term number. So if they ask you for term number 25, you're going to make your N values 25. Let's actually do that. So let's add here at the bottom, calculate the 25th. Oh, I'm sorry, that's very old screen. Calculate the 25th term. If they're saying it's term 25, the 25th term, that means that N is 25. That's the one thing that's the same from a linear pattern and a quadratic pattern. N is always the term number. So we're going to say term 25 instead of term N. Then I'm asking for term 25 is 2 times 25 squared minus 3 times 25 plus 1. So again, you're taking your formula, your rule that we calculated here. This is a rule that will give you any number, any term in the number pattern. So they're asking for the 25th one, you're making your N value 25. Let me just quickly work that out. So you'll take your calculator, that would just be the fastest way of doing it. And you will get 1176. Any questions so far? Yeah, I do want us to answer just 2 more questions based on this, but let me just get my spacing sorted here quickly. Okay, the next question is, write down the next three terms. Just write that quickly for me, please. Write down the next three terms. Now, guys, it is a bit more complicated when you have to find the next three terms of a quadratic number pattern. For linear pattern, it's easy. You just add the difference again. So if you were adding 3 each time, you just keep adding 3. Now we're not adding the same number every time, right? So we had, when we started out, it was, you don't have to, I'm just going to copy and paste it, but you have it on your pages there. I'm just going to do this, so you can just look back at that. But I don't feel like rewriting it now. Okay, we had this situation, right? This is the number pattern. Now, guys, if we need to get to the next term, I'm not going to add 15 again. Remember, the first difference is not the same. I need to add 19, 4 more than 15, hey? So actually, you need to keep going with your second difference. It must be a 4 again. And then your first difference that you're going to add here is going to be a 19. Right, so it is a bit more complicated. So you need to look at what was my last first difference, 15. Now I must add 4 more. I must add 19. Okay, so what term number will that be? 1, 2, 3, 4, 5, 6. The next term that we're going to get is term 6. So guys, I suggest that you actually write it down like this. You say what term 5 was. So term 6 is going to be term 5 plus 19. Or if you want to break it down even more, you can say, you can write it like this, term 5 plus 15, but then plus 4. That's where that 19 is coming from. Okay, but I think you can do the 15 plus 4 in your list. Okay, but if you don't want to, if you want to rather play it safe, you can do it like that. What was term 5? Term 5 was 36 plus 19. And that is 55, yes. Okay, so term 6 is 55. It does take a bit longer to write it out like this, but it's quite easy to get confused, right? And to forget what you're supposed to add. So that's term 6. Now we need to get to term 7. Now term 7 is going to be term 6, the previous one, plus. What is my difference going to be now? Now it needs to be 4 more than the number I added the last time. So 4 more than 19. So 23. Okay, so you really need to have your work about for these types of questions. So it's going to be term 6, which we calculated was 55 plus 23, which is 78, if I'm not mistaken. And then the last one, because they asked for the next 3 terms, right? So we need to do 6, 7, 8. I'll just do it on the side here. Term 8 is going to be term 7 plus, again, 4 more than the number we added the last time. So 27 this time. So that is going to be 78 plus 27. Is this now 105? Okay, so 105. As you get more comfortable working with these, you can put it on a calculator as well. You don't actually have to write down that the calculation that you're doing. You can just say, okay, I'm looking for term 6. So I have to take the last term that I have, 36 plus, what's 4 more than 15? 19. But then you must just remember what you added the last time. Now next time you're going to have to add 4 more than 19, which is 23. But then you can just say answer plus 23. That's the next term, 78. Now you must add 4 more than 23, which is 27. And then you get 105. Okay, so that can save you a bit of time. But let's just write it down like this so that we know exactly what we did. Okay, one last question. On the page. Okay, are you guys up? Copying this one. Which term in the pattern is equal to 17,020? Whereas we have done questions like this before, where they're asking you which term is equal to a specific number, and then we always make that number equal to Tn. Right, so if they're giving you an actual number that's in that number pattern and they're asking you which term is it, right? You need to find out what the term number is, and the term number is always in. So what we're going to do is we're going to make our formula that we calculated equal to this number. Right, so remember we found our whole an squared plus bn plus c thing. What was our formula that we worked out again? Was it 2n squared minus 3n plus 1, right? That's the formula that we got. But we're going to make this formula now equal to this number. Okay, so always when they're asking which term is it, then that is what you need to do. You're going to take your formula that you calculated, 2n squared minus 3n plus 1 equal to the number that they're giving you. Hello. Now, what type of equation is this? Quadratic, okay? What do we have to do every time we have a quadratic number pattern? Everything on the one side equal to 0. So 2n squared minus 3n. Here we have a 1. And now we're going to subtract 17,020 from it. If you're worried that you're going to make a mistake, you can do it on the calculator. But it's going to be negative 17,019, isn't it? So guys, do we want to factorize that one? No, definitely not. N is equal to, we're going to use the quadratic formula. Now we can't write x equals, because we're not solving for x here, hey? We're solving for n. Do we remember the quadratic formula? I'll write it on the side. Yes, x is equal to minus b plus or minus square root. We haven't used it in a while. B squared minus 4ac. Yes, over 2a. So that is what we are going to use now. Obviously, our c value is a very big number, but that's fine. We can still just type that into the calculator and get our answer. But guys, it's very important if you write x here, you might lose a mark because we're not finding x. Okay, we're finding x. But it is a quadratic equation, so we can use the quadratic formula for it. It's an n squared equation. Right, so we're going to say, what is our b value here? Negative 3, right? So we're going to have negative 3 plus or minus the square root of b squared. So negative 3 squared minus 4 times a, which is 2, times c, which is negative 17,019. If you forget that minus, the calculator is going to say math error. Okay, you have to please remember the negative there in front of your c value. And that is then all over 2a, so 2 times 2. Okay, I'm also just going to type it in quickly. Okay, so I'm getting 93 for my first answer. But remember, with the quadratic equation, you always get two answers, all right? So you do have to go back to your calculator, change that plus to a minus. And now, yes, a fraction, or you can change it to a decimal, negative 91.5. Now, guys, we did discuss this yesterday when we were marking. When you are finding a term number, it can't ever be a fraction or a decimal, right? The term number always has to be a whole number. So what you have to do is you still have to write this answer down. So you need to either write negative 183 over 2, or you can write the decimal value of that if you want to, but the fraction is also fine. But then, guys, this is an invalid answer. It's an answer to this equation, right? But in the context of a number pattern, that can't be a term number. In the first place, it's negative. We can't have negative term numbers, right? We start at term number 1, then 2, then 3, then 4. We can't go back into the negatives, and it's also a decimal or fraction. Okay, so we can't have that. So you have to write it down. You get a mark for actually writing it down because we are solving this equation. But now, because it can't be a term number, you need to draw a line through that equal to show that in this context, actually n can't be that. And you are going to have to write underneath invalid. So what does that mean? Which term is equal to 17,020? Term number? 93. Good. So we need to just end our question or our answer off by saying, therefore, term 93 is 17,020. And guys, that will actually always happen when you are calculating a term number for a quadratic pattern. You will always get two answers and one of them will be invalid. Because if you're just thinking of a number pattern, right, where you have a constant second difference. So you're adding a bigger number each time. You can't have the same number twice in that number pattern, right? A number pattern doesn't go up and then start going down again. All right. So you are supposed to only get one answer. So guys, they could have asked this question differently, the wording. So I just want you to add this to the bottom. Note that we use the same method if the question states because this is actually how the question is written in the exercise. So if they say, given, I'm sorry, now we're going to write this number pattern out again, but I promise it's the last time. 0, 3, 10, 21, 36, and then they do a dot, 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 and then another semicolon, and then they give that 17,020. Calculate the position of the last term. So guys, the fact that there is no dot or dot after that 17,020, it's showing us the number pattern stops there, it doesn't carry on further. Right, so they just say calculate the position of the last term, the term where it stops, where there's no dot 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 in here. That is the last term, 17,020. Right, so again, you're going to make that equal to Tn and solve for n. It's going to be exactly the same working that we just did. The question is just written in a different way. Or they can also ask, they can give you the same number pattern and they can write so that it stops there. Or they can ask, calculate the number of terms in this pattern. I'll just say number of terms. Again, you are going to do the same thing. Exact same calculation. You're going to say, okay, now they're asking for the number of terms. Guys, number of terms is also n. Right? But now our final answer is going to have to be written slightly differently. You are still going to make this equal to Tn. Right? Exact same calculation. You're going to work it out, move the 17,020 across, do your quadratic formula, everything that we just did. You are going to get an n value of 93, all right, which is what we got there. So we're going to get that this is term 93, actually, right? We said that 17,020 is term 93. Now, guys, if that is the last term, and it's the 93rd term, how many terms are in the number pattern? 93. Okay, I'm going to say that again. If you calculate which term this is, right, just like we just did the calculation. We're calculating that this is term 93, but it's the last term of the number pattern. There isn't going to be a term 94 and 95 and 96. It's going to stop at term 93. Does it make sense if there are 93 terms in the number pattern? Because that's term 1, term 2, term 3, term 4, all the way up to term 93. Right? So if you calculate that this last term is term 93, that means that there are 93 terms in the number pattern. So then instead of saying this as your final answer, you will just add, so I'm just going to say here in blue, add to final answer. Therefore, 93 terms. So just if you're asking for the number of terms, you're just going to say 93 terms. Right? So you find which term that is, and then that tells you how many terms there are. Okay, I'm going to give you some of these to practice on your own. It's basically what we just practiced. The way that it's written in the exercise is a bit strange though, so I just want to show you quickly that it is exercise 3 in the textbook. On page 49. Want you to do, I'd rather just make it 1 to 3. I'll put it on the board now, and then I'll also just explain to you. They've kind of like written it in like a paragraph, what you just have to do. Not laid out very nicely. I'll just give everyone a chance to copy that down, and I'll put it on the board. Goodbye. Okay, guys, I don't know whose book this was, but they did actually. They did break up the question into like 1, 2, and 3. So they're saying consider each number pattern, and then the first thing that you need to do, you can see they wrote a little 1 there. Write down the next 2 terms. Then you're going to determine the formula, which is the Tn thing. And then number 3, now determine how many terms there are in each sequence if the value of the last term is given. So that's what we just spoke about, guys. They're saying here in the first question, the last term is 667. So you're going to make 667 equal to your formula, solve for n, right? That is then the number of terms. Okay, so if you're getting like we did, n is 93, that means that there are 93 terms. Okay, so whatever you're getting for n here, when you make term n equal to 667, that is your answer. You just have to say that number of terms. Okay, you're doing 1, 2, and 3, guys. So you're going to do 1A, 1B, 1C. Does that make sense? Can we do A, B, and C? I prefer A, B, and C instead of these 1, 2, and 3 things. So I'm going to write here, this would be A. Write down the next 2 terms. B is then determine the formula, and C is then determine how many terms there are. Okay, 1 ABC, 2 ABC, 3 ABC. Okay? Keep going, guys. You have 15 minutes. If you work fast, you can finish it in that time. And then tomorrow, you must bring your proof sheets if you started working on them. And I'm going to do a little bit